everybody. This is Chuck, and as always, I want to thank you for stopping by my shop. And as for starters here, I noticed most of my videos, I talk very fast. I'm really worried about time. I appreciate your time and spending it with me, and I think a lot of times I go too quick. I'm too worried about that. I'm going to try to do a little better tonight. But again, thanks for stopping by. So this is another video on the Mill Vise, the Morrison and Marvin Engine Works Mill Vise, and I'm going to talk about a couple of the items that I've just finished. And here's the drawing here, and it's the screw and the caged bearing and the what else we have there, and there's a locking collar also. So some of this was shown a little bit in version 2 or the video 2, but this was a heck of a learning experience. I did show you in the video 2 was thinning the tap, which is right here, left-handed tap. I did show you that. That was interesting to do on the surface grinder, and then I also showed in a video using the Rotary laser and marking the tap itself, so I knew what size it was since I had ground it off. It's been an interesting project so far. As I said in the beginning, this was a little over my pay grade, or a lot over my pay grade, but I've been having a lot of fun with it. I have, of course, Carl in my back pocket, who I counsel now and then Dave Otto, who has built 4 of these. He has pictures up on the web showing the various stages of the build, so it's very handy to be able to go and reference that. But anyway, just going to talk about my learning experience here. The caged bearing, the diameter on the print here is 390 thousandths with a interior bore of 250 thousandths, and the bearing itself, when you create the hole for the bearing, the ball bearing itself, you have about 4 thousandths on each side of wall thickness. A little more than a human hair. And I had a failure, and we're going to talk about that and talk about what I learned in doing it. I don't know if this will come up on the camera, hopefully, but there's the bearings, very, very small, as you can see. They're 1.5 millimeter bearings. And then there's a little brass piece in there, and I hope that comes up. We'll talk about making that also. That's the set screw collar pad, set screw pad, so that the set screw doesn't mar the threads. So we'll move on right now. Again, I'm going a little slower tonight, and I hope you appreciate it. Hope it works for you. We're going to take a walk down, handheld here, or I'll move the camera. We'll go down there, and I'm going to fire the camera back up, and we'll talk about something else, and then we'll get on to the vise. Well, I've been meaning to do this, and I keep forgetting, but there is one of my tooling cabinets with stickers on it. And recent stickers that have come in are here down at the bottom, and it's a Moose Hill Machine, Knox I've had for some time, Jim's Workshop, another home shop guy, Joe Pye, Foxberg's Fabric Oven, what a name. Great guy though. Boy, there's a couple of vices he got. Yikes. And old buddy Harold. So there's the board, and then actually I had a previous toolbox that had stickers on it, and then there's a toolbox down at the other end that has stickers on it. But oh, Mark Presley also got that. So I got some more stickers coming on the way, and I thought I just wanted to mention that. But over here is the vise. It's assembled right now, and let's go down the table and we will take it apart and talk about it. Before I take the vise apart, I just wanted to show you, I have the electronic microscope. This was from Banggood. I did a review on it years ago. It's been a great little tool. And you'll see a shot on the mill where I'm using the surface gauge or height gauge as the mechanism to hold the camera. Modified it so it's really, I can take it anywhere. You can unplug it, runs on battery. And there's a picture of this little guy right here. That's the 390 thousandths across there. And let's bring it up here, and you can see the clearances. And you'll notice that they're not consistent. Fairly consistent, but not exact. Hey, I'm a hack, buddies. So we're going to talk about this guy, but this is the remnant that after the cage bearing was complete. So let's move down to the other side of the shop and we'll talk about this some more. Let me pull this out. I'm going to unscrew it. So there is the piece that I made. It's got a 1/4-20 thread on it, and that 1/4-20 thread goes into my rotary table. And then this boss right here, there's a counterbore in my rotary table so that that would center up as I threaded it in. And then this was the rough diameter of the part. And there's the this is a little over 390 right here, and then where that little step is right there, that's the 390. It's actually 396 to be exacting there. All right, let's go down. Okay, so just a little recap of what we have here so far. We got the bed of the vise. There's the nut. The nut is what holds the block. The block, which is your movable block. So this actually has your block and your fixed jaw. That's an upcoming build there. But so there's the screw. It's got the hex cut on it. That's for the handle. It fits on there. I'm doing it backwards. I still need to file the casting. It won't go on this way. But it shows you that the nut is movable. And we have the locking collar on it. And then inside here, you can see that there is a step in the shaft itself. I don't know if you can see that or not. We're going to take it apart. And inside there is the caged bearing and the made out of brass. There's a picture of it. just what I had showed you there on that stem. Let me take this apart. So hopefully you can see that. That's the collar. It's got the set screw in it. It's a 172. Here's a photo of it in the mill getting tapped. I don't know if that's picking up on focus or not, to be honest with you, but it's a small guy. Put that over in the tray there. And then when we take the vise out here, there's the bed of the vise. And so you see here is the screw, and there is the bearing collar, and it has two thrust washers. The thrust washers were provided in the kit. Now, the bearings are over here. I have not put the bearings in the thrust washer because this is going to come together a few times and I'm not going to lose those little balls. Hence I put them in the little tube there. But these fit real nice, very tight. So there's one thrust washer. There is the caged bearing. Another thrust washer, and then the actual screw. Which goes all the way through the nut. Hence, that's why I had to relieve the tap to get the tap to go all the way through the nut. The nut is machined, it's all complete. There is a flaw here in the actual casting the way it came. I'm not going to mess with that, just going to leave it. And then here we have the screw. So we have 1/4 28 on this side, right hand threads, and 1/4 28 left hand threads on the other side. This boss here is what fits in the vise and creates the center up for the nut. But let's talk about the, where'd it go? I thought I brought it down here. There it is. Let's talk about the caged bearing. Let's flip to some photos. And if you notice there is a concentricity error. And you can see that I had XY coordinates, and I just assumed, this was just part of learning. Again, sidewall, 4 thousandths clearance on each side of that hole. I was off, and I went at it with the first two holes in that picture, I went at it with a drill bit, and they blew out outside. And I said, geez, I bet you the drill bit just pushed. Well, the part was already fouled, so I said, okay, well, I'm going to go in with an end mill. So I went in with this 1/16 end mill, and the hole was perfect. And then I tried again, moved over, and then the next one blew out on the inside. Showed me a concentricity error. That was holding it in a V-block, XY moves. Now, I went to go to build it a second time, hence when I made this piece. So this, as I said, sits in my rotary table, and now all I had to do was move the rotary table and not move the mill. Get it lined up and be good. So what I actually did is I touched off. I came down with a 1/16 end mill. In the plans here, say drill and ream to 1/16, and that was kind of my thought in the beginning. And I actually let me just talk here a little bit further here. Why is there a different dimension right here and right here? This was bigger. This was like 410 something. This is the supposed to be 390, and I went 396. So we'll talk about that in a second. So my initial was go large on the diameter, go undersize on the interior bore, not the 1/4 inch, and then use the rotary table with a boring head. And the boring head would machine the outside and machine the inside to get me concentric. So I made this pin, and I was walking down to start, and I got to tell you, my head rang, and I said, man, that's going to be a lot of work. Thought about it, I said, you know, Chewy, who I miss dearly, he's passed on, he used to always tell me, you got to know how to cheat, Chuck. You got to know how to cheat. You got to learn how to cheat. And as I was walking down to the mill, I said to myself, man, I can make another mistake if I have to. I've got enough shaft here. So I came back to the lathe, turned this to the 396, and created the 1/4 inch recess. And there again, you might be able to see that there's a step there where I actually had the bore smaller. Installed this in the rotary table, cheated, and used a 1/4 inch gauge pin to get center on the rotary table, 0, 0. And then I just had it offset over to one spot. I think it was 162 thousandths when you look at an actual CAD drawing. As I knew the dimensions were so tight, I thought about it and I said, well, wait a minute. The bore that this guy sits in and that the cage bearing sits on, this is 400 thousandths. And I said, well, why is this 390? That's 10 thousandths. So I cheated. I kicked this up to 396, picked up what, 1.5 each side, 3,000. I picked do the math. But anyway, yeah, you gotta say it. It got me a little more space to make this work. So here's a video, or I think it's a video of the microscope. So I came down, I touched, just glazed the top, and then looked at the concentricity of my hole with this land for it to sit on, and it was good. Just that little touch off. So I rotated the vise, I think it was 144 degrees, touched off on another one, and it was close, but it wasn't the same. And I started to see what I needed to do. So I came back to my initial point and did not touch it. And I moved over one, dusted it again, saw where I was, and I can't remember, to be honest, if I was on or off perfectly. Raised the mill table 100 thousandths and plunged in with a 16th end mill, and success. Pulled back out, dropped my table 100 thousandths, rotated, came down, a little dust, made sure I was okay, raised the table, plunge again with the end mill. So as I went around these 10 holes, I had to look at each situation, and I was basically moving the mill in the Y direction 100 thousandths, just to assure that I was in my best location. Off I went, got all the way around, everything's going great. I get over here to hole number 9, and remember number 10, I should say. Number 1 I never did, and actually on one of these I moved the mill, and I was ready to go, and I went, no, you just moved it the wrong direction, and I caught myself. So didn't bozo or Charlie that one, right? And now I'm starting to stress. I'm getting too close to finishing this part, and the stress is just rampant. Finished that hole, and then I went back to my starting hole that I didn't complete, and I said, oh man, this son of a bitch is going to be the kiss of death. But hey, I got through it. So add all 10 holes in here, and then the next thing that you need to do is come over and part it off on the lathe at 50 thousandths. And that one's successful. So there's the cage bearing. And like I said, I haven't put the balls in it yet because I'm not going to lose those balls. So it's been a very tedious and learning experience. I learned a lot, and in full disclosure, when I started with the XY movements on the vise, with the unit held in a collet, had it in, I think, in a ER collet. I did not use an indicator to indicate the part in. I went in with a pin and used the pin to align it. Lazy. And I'm not that good, I gotta be honest with you. You watch these guys with they take the indicator and they spin it around the 10th indicator. It's a chore here. I mean, I can do it. Oh, there went my lights. Hang on. I know. Everybody says, why do you have it on a timer like that? Or it just shuts off automatically. But I have emergency lights in the ceiling. If the machines are running, they have actual machine lights, so I'm safe. So I said that I didn't indicate it in when I had the ER collet. I did the same thing again when I went back, and I used a pin to locate this on the rotary table. It's a cheat, it's not precision, and I managed to cheat my way through it. So a lot of lessons there for myself, learning and doing this, and it's been fun. Now this collar set screw pad, which sits inside of there, in that underneath that set screw, the 172 set screw. Well, that guy is 62 thousandths in diameter and 20 thousandths long. That's a test. So I said, how am I going to build that? So I went over and got some brass welding rod and put it in the lathe. And a shop gem from Joe Pye, he talked about it in one of his videos, where when you have a very, very small diameter, there was no way on getting down to 62 thousandths that I'm going to go in there and continue to turn the part down. the tool bit's going to push the part away. It's just too narrow, even though the stick out's next to nothing. So Joe Pye shop gem was pick your diameter. You know, I touched off. I knew the outside DRO set. Go right to your number and just run it, and it worked like a champ. Just whoop, whittled it right down to the 62 thousandths without any deflection, and then I had a part off 20 thousandths. So I have thin bit parting tools. Let me grab one. I don't know if you guys are aware of these or not. It's a product called Thin Bit, Kaiser tool. This is a 3/8 right hand, and you can see the very, very thin parting blade there. These, you'd be surprised, guys. You go try to buy one of these tool bits, you'll be shocked. They're $100. I didn't pay $100. I've got a collection of these that I've managed to purchase, both tool holders, and I have the actual turning bits in different, 10,000s, 20,000, all sorts of sizes. Handy to have, though. I couldn't have parted it any other way. So, as I mentioned, in here, there's a little piece of brass, and I just can't tell on this camera viewfinder if that's clear or not. But anyway, so I machined it, parted it off, had it in a little plastic catch tray, and hey, fantastic. Well, when I parted it off, I ended up, it's so small that of course I had a little nub, a little tit from where the parting tool were. And even though I ground the parting tool to cut the off piece first, I still had this little tit. Unbelievable how strong that little tit sticking out was. So I had two pairs of tweezers here, and I'm holding the part in one hand, one tweezer, and I'm trying to just slowly break that little tit off, right? It's you can't even see it. All of a sudden, pick, off it goes. The tweezers close, the part, adios, goodbye. So I go back to the lathe, make another one. Same thing, come back over, I'm sitting there fighting, trying to get this thing off. I even brought a little stone over, I was trying to stone it. All of a sudden, tick, gone again. Oh my gosh. So, go to the lathe, make a third one. Back over here, fighting. And I finally said to myself, this is a losing battle. I think Chewy must have been channeling to me, to be honest with you. Figured out a way to fix it. I've got some nice Moore 1, 2, 3 blocks here. So I set the part on the 1, 2, 3 block, the tit sticking up, put another 1, 2, 3 block on top of it, whacked it with a hammer, right? Nice and parallel. And of course the tit, that little teeny tit, flattened off. It's a non-subject. So that's where I'm at. Everything on this page is done. The screw's done. The bearing races are provided. The pad is built. The collar's built, and the bearing cage is built. Been a heck of an experience, learning, and going to move on. The next thing, as I mentioned, is the nut. And you see I blued it up, and I've been studying the drawing, which is this guy here, and I've been putting down dimensions that are built and what is rough, and I've been trying to understand my starting point. Someplace, and I've got to do a little more homework, someplace, this has to sit down on the vise. and there's a datum that I got is your starting point, and I'm working on figuring that out. Back to the vise bed itself, wherever it went, here it is. The vise bed, this hole where the screw sits down in. I've checked all this, and the height from the vise bed to the center line of screw is right on the money, and so hence I've got to figure out that block, because there's a dimension there that has to fit. So that's where we're at on the vise build part 2, or part 3, excuse me, part 3. It's been a challenge, and let me see, turn you around here. Hear my phone dinging there. It's been a challenge, and I'm enjoying it. There's a lot to go still, and we'll keep trying to get things done and pop out another video. So with that said, I'm out of here. I appreciate your time as always, and I hope you found this enjoyable and my pace a little slower tonight. Take care, everybody, and catch you soon. Well, you saw my failure, so this is my next attempt. Put my rotary table on the mill, centered up on that hole. I've cut a dimension on this spud that fits that hole, and it's a 1/4 20 thread. So this will thread in, and then I've already machined the outside and inside, and I'm going to use the rotary table to put the 10-hole pattern in. We'll see if it's successful. Here we go. This will just screw down in there. Go all the way down and give it a little tighten.